The catapult. A fearsome weapon of war that was in use as early as the 4th century BC by the Greeks and the Chinese. It has stood the test of time and proven its worth in times of hardship, in a remarkably similar fashion as how we students of ENGR 1120 prove our worth in finals week. For our project, we designed a catapult. We wanted to create something that was simple yet mechanically interesting. Our final catapult assembly displays the use of constraints, motion, and design-accurate part modeling. We chose to design a catapult because it allowed us to demonstrate all of the skills learned during the inventor unit of this class: sketching, extrusions, constraints, joints, assembly, and motion. Our motivation for designing a catapult for this project was that it is a fundamental example of mechanical engineering, composed of simple machines. Our catapult combines rotational motion, energy storage, and structural support. It demonstrates how individual parts can be combined to perform a mechanical task. Each team member designed and created unique components which were brought together to form the final assembly, which is intuitive yet simple to understand. My name is Arjun, and I helped to design and model the base component of the final assembly of our catapult, and I also helped contribute to our presentation.
Hello, my name is Sam, and I'm one of the engineers of this project. I was responsible for a couple things. Firstly, the lever arm of the catapult, which uses torque to launch projectiles at high speeds. This lever arm swings on an axle pin, which took the form of a simple cylinder, designed to keep the various aforementioned parts in alignment with one another. Lastly, I designed the bucket that holds our projectile, a simple wooden cup affixed to the end of a lever arm. I also handled editing of this video, so I hope you enjoy it. Moving on to Brandon, our weapons specialist.
For my part, I created the bars that hold the catapult up, and I also created the ball using the sphere tool in Inventor. That is what I did for my part.
Hello, my name is William Kim, and I was tasked with making the full assembly of the catapult for this project. Here we have the full assembly of the catapult, and we also have the exploder view as well. So just to name the main components of the catapult, we have the cup, the stopper bar, the board, the base, and we have the rod. So the cup is there to, be attached to the board so it can hold the projectile. The stopper bar so it stops the board from moving. So when it has that sudden momentum stop, the projectile will be shot over. Then we have the base, which holds everything together, and the rod is where, the board can pivot and actually move and launch the projectile. The rod and the cup were made using the revolve function in Inventor as well, and everything else, same as the projectile as well, was made through revolve, but everything else is made through extrusions. And yeah.
Throughout this project, we honed our skills in creating precise sketches with constrained parts, using extrusions, revolves, and other Inventor functions to create these parts, applying geometric constraints and assembly constraints to the final assembly, understanding proper fit relationships between parts in the final assembly, and collaborating in a CAD workflow.